Let's spend a few minutes talking about function notation. I want to make sure that you have a good conceptual understanding of the notation when we're writing functions. And this will be important as we start to deal with new functions down the line. So another way to represent an equation that is a function, instead of using y equals, is we can use f of x. For example, f of x equals 2x plus 7 instead of saying y equal 2x plus 7. Now, I usually say f of x, but we should be a little more careful maybe in the beginning saying this means the value of the function f at x, at my input x. So f of x equals 2x plus 7. It's really important that you don't think that f of x means f times x. We're not saying that. I know if we're dealing with numbers, like if I wrote 2 and then a 3 in parentheses, that means 2 times 3, which is 6. But f of x is different. This is function notation, so we're not multiplying things. And that's really important later on when we start talking about log functions and trig functions with this notation with the x in parentheses. So I want to make sure that that's really clear. We're not multiplying the letter f times the letter x, like they're two variables. Okay, so, and this function here is saying, take the input, multiply it by 2, and add 7. And I want to start thinking of when we see a function notation like this, I want you to think of this is the input, and then this is the expression dealing with that input. So let's look at an example. Here I have f of x equals x squared minus 1. I like to think of this, when I see this, I say, oh, the function f squares the input and then subtracts 1. I could have used anything I want, and I'm going to evaluate these. But, for example, I could have called this f of triangle equals triangle squared minus 1. Or I could have called it f of t equals t squared minus 1. Okay, I can use anything I want to represent the input. Usually we use the letter x because we tie this together with a graph, and we graph in the coordinate plane with x and y. All right, so I want to evaluate each of these. So what does this function do? It squares the input and then subtracts 1. So let's do that process. So let's calculate f of negative 3. Well, what am I supposed to do? I'm supposed to square the input and then subtract 1. Notice I wrote the negative 3 in parentheses here. I want to make sure that we understand we're squaring the negative as well as the 3. So if you just typed on your calculator, let's say negative 3 and then hit the squared button, a lot of times calculators would wind up showing that, which is incorrect. Although it's incorrect for what we want, but not the way we entered it. So we need to use these parentheses with a negative. All right, so when I do negative 3 times negative 3, I get a positive 9, and then I subtract 1 and I get 8. So f of negative 3 is equal to 8. All right, how about, let's switch colors. How about f of x plus 1? Once again, remember, what does this function do? This is the input. It squares the input and subtracts 1. Whatever the input is, it squares it and subtracts 1. Okay? My input is x plus 1. So I need to square that and then subtract 1. Well, what's x plus 1 quantity squared? Well, I'm going to have to multiply x plus 1 times x plus 1, and then I need to distribute, or a lot of students remember FOIL. So I have to multiply everything in the first parenthesis by everything in the second parenthesis. So I'm going to wind up getting an x squared plus 2x, when I combine like terms, plus 1, and then don't forget I still have to subtract 1. Well, the 1's will cancel, and I'll wind up with x squared plus 2x. So f of x plus 1 is x squared plus 2x. Okay, let's try the next one. How about f of a? Well, what does the function f do? It squares the input and subtracts 1. And then there's nothing else I can do. That's as simplified as I can get. That was easy. All right, and then how about the last one? What is f of x plus h? Well, I need to square the input x plus h squared, and then subtract 1. Now when I square x plus h, just like I did before with the x plus 1, I'm going to distribute x plus h times x plus h, and I'm going to get x squared plus 2xh plus h squared, and then don't forget subtract 1. There's no like terms here, so that's as much as I can do, and that's your answer. Okay? A specific type of function that'll start showing up, and a lot of times in some real applications, piecewise functions. A piecewise defined function has different rules assigned based on the inputs, the values of the inputs. So, for example, here's a piecewise function. And it has 3 pieces. And everything is based on the values of the input. So my input is x, and this specifies values for x. So anytime x is less than or equal to -2, I'm going to take the absolute value of that input, multiply by 2, and add 1. If my input is between -2 and 0, not including either of those endpoints, anywhere in between -2 and 0, I'm going to square my input and subtract 1. And then anytime my input is greater than or equal to 0, I'm just going to subtract 3 from it. So I have 3 different rules here depending on the values of my input. So let's evaluate these. All right, the first one is f of 1. So what is f of 1? So that's right here. All right, so step 1, you need to say, okay, if my input is 1, which category does that fall into? Is it greater than or equal to 0? No. Oh, yes. I'm sorry. It's not less than or equal to -2. It's not between -2 and 0. It is greater than or equal to 0. So this is the rule I'm going to use. I want to do x minus 3, or the input minus 3. So my input was 1, and I'm going to subtract 3, and I get -2. Okay, let's try another one. How about f of -2? Which restriction does that fall under? Not this one, not this one here, but this one here. Less than or equal to -2. So when my input is -2, it falls under this restriction. So I'm going to take the absolute value of the input times 2 plus 1. So I'm going to do 2 times the absolute value of my input plus 1. The absolute value of -2 is 2, and then multiplied by 2 gives me 4, and then I'm going to add 1 to that, and I get 5. So f of -2 is 5. All right, how about f of 0? Okay, which one should I use here? Well, my input greater than or equal to 0, this is the one I want to use, so I'm simply going to subtract 3. So all I'm going to do is my input minus 3, which is -3. And then lastly, let's do f of 3. And once again, figure out which one we're looking at here. My input is 3, not true, not true. It's true here, so that's what I'm going to use. So I'm going to take my input and subtract 3 from it, and I get 0. So once you understand what the notation means for piecewise functions, it's very simple. Look at your input, decide which rule applies, and then evaluate that expression with your input. And that's it.